There it goes. All right, there we go. Parent function of cosine. It's going to have that same kind of initial period as sine did, because to go all the way around that circle, we go around 2 pi. The parent function, since it doesn't have anything in front, we have that amplitude of 1. We're going to start at 0, and we're going to end at 2 pi. That's how long it takes to go around the circle. So those pieces are the exact same as our parent function from sine. We're still starting at 0. We're going to go all the way around to 2 pi. What is different between sine and cosine at 0? What is cosine?
Y. No, I mean X.
The x's. So at 0, if we think about our unit circle, oh snap, if only it was fresh in our minds. What? So if we think about our unit circle, at angle 0, what's the value of cosine?
0.
1, 0. So our ordered pair here is 1, 0. So which one's cosine? 1. So cosine is not going to start at 0, 0. It's going to start at 1. Which is why I kind of thought through these pieces first, because since it's not starting at 0, we need to make sure we pay attention to our amplitude, because this is going to be up that amplitude here. So it is slightly different. We have to be really careful. When we get to our, oh, helps if I number my x-axis. I'm going to do the x-axis the same way we've been doing with our pi over 4. Is that dark enough to read? Kind of. I'll make it a smidge darker. Our pi over 2, 3 pi over 4, and pi. 1, 2, 3, 4. 2 pi. So I'm just counting 4 spaces to a pi. 1, 2, 3, 4. I'm just numbering my x-axis. I forgot to do so. Minus 2 pi. Since we're on our parent function, I'm going to kind of use that one we've been using. Nothing's going crazy with it. If you want to look at these in-between values, you absolutely can. But if we think about what our cosine is for pi over 4, that's going to be our square root of 2 over 2, which is super gross, and I don't know where that is on a graph. Ugh. Ugh. So that's why we tend to go with our quadrantal angles, because anything in between is decimally and gross. I would like to avoid that. So at angle 0, we're at 1. When we're at angle pi over 2, we have the ordered pair of, what's our ordered pair for pi over 2? 0, 1. So what's our cosine? 0. It's our x's. So for pi over 2, we're down at 0. What is our ordered pair for pi? Negative 1, 0. So what's our cosine? Negative 1. So when we're at pi, we're at negative 1. One more quadrantal angle. What's our ordered pair for 3 pi over 2? 0, negative 1. So our cosine is 0. Am I making things hard to see up here? If I ever have something that I can help and change the zoom on, please let me know. I'll make my dots a little bit bigger so we can see them. Okay, and then we go back to our beginning and we get up to 2 pi. What is the value of cosine at 2 pi? 1. So that's one cycle through cosine. It still goes down to 0 and back up to 0. It's just like off a cycle. Like it feels off. But all it is it's just kind of the same value. It's just a little bit shifted. So when I'm filling in my dots, I always kind of think of 1, skip, 0, skip, negative 1, skip, 0, skip 1. And I'm just going to continue that pattern. So we're going to skip 0 on that side, and I'm at the end of my graph. Skip 0, skip, negative 1. Skip 0, skip positive 1. Just to help me kind of spot the pattern when I'm filling things in, to get all my points. So our initial period was this guy. And then the rest of our graph, filling that in, we get this. It's gonna keep going out like this. So it looks really, really, really similar. Super duper similar. Because they are related to each other. They're going around that same circle. They're the same values, just kind of off. So, what is the domain of cosine? Negative infinity to positive infinity. And again, that is going to be true for cosine forever. What is the range for cosine? From -1 to 1. With brackets, because it's included. Because I have values at 1 and I have values at -1. Okay? So we still have that same initial period that goes for 2 pi. That's our period. And again, you don't have to draw this on here, but I just kind of like to show us what all those things are talking about. As long as you have the period indicated when we need it, you don't have to draw it on the graph. I'm just trying to make sure we see where it is. We started at our left endpoint was angle 0, and our right endpoint was at 2 pi. Because that's how much it takes to get around the circle. The trickiest part with cosine is remembering that we start and end at our amplitude up from the center. Because things get a little kooky dukes, a little crazy when we start moving things around. Speaking of crazy things that move things around. The transformations that happen to cosine are exactly the same process as what happened to sine. So we're going to practice all those transformations using cosine. Okay? Questions on this one before I take it and make things go a little wild? I mean, it's not anything different. It's the same transformations. We're just going to have all 4. Okay? Ready? Same chunks. So just like before, our A is out in front, our B is inside with the X, the H is inside with the X, and the K is on the end. So we're going to do 2 cosine of 1/2 X minus pi minus 2. So before I number my x-axis, I want to figure out a couple of things. I want to figure out my period length, and I want to figure out my endpoints, for sure. And before I start drawing, we need to figure out what happens with the vertical shift. So for our period length, that is when we take the normal period for cosine, which is 2 pi, and we divide it by that b. So we're going to divide by 1/2, this guy. So what is the period length for this particular problem? 4 pi. So if I had already numbered this and counted, I would only be at pi and 2 pi here. I would not be able to fit, bless you, 2 whole periods on the graph. So that's why it's really important to figure out the period length before we number things. I also highly recommend doing our endpoints so you don't wind up with stuff being between. So to find our endpoints, that's when we take what's inside, this guy right here, our minus, oh, that's not a pen, our 1/2 x minus pi, and I want to know what would it take for that thing to be 0, where we normally start. So we're going to add pi to both sides, so we're going to have 1/2 x equals pi. So our starting point is actually at 2 pi. We do a very similar thing for our right endpoint. So we're going to figure out when our 1/2 x minus pi would reach that normal endpoint where we normally get all the way around the circle, which is 2 pi. So then we have our 1/2 x, add pi to both sides, so we're going to have 3 pi. So our right endpoint is going to be at 6 pi. So we want to make sure we can get all the way up to 6 pi on our x-axis. So not only is our period length 4 pi, but my right endpoint is at 6. So we need to make sure we can get out that far. So you could count by pi's. You could count by pi over 2's. I'm going to say, if you go by pi over 2's, you do wind up with our 6 pi being right here. Just saying. It works, but it's not super pleasant. So I'm going to count by pi's. Just because we don't have any weird, like, in-between things happening, so we can do that. So we're going to go pi, and 2 pi, 3 pi, 4 pi, 6 pi, 8 pi, blah, blah, blah. And then we'll have the same thing the other way. We'll have our minus 2 pi, skip minus 4 pi. And you don't have to number the whole thing, but just enough to get the vibe across. And we need to be able to fit 2 entire period cycles on the graph. That's what we need to fit. So before I do any more points, or before I do any points period, we need to figure out where the center is, where our midline is, and we need to figure out our amplitude. So we have, okay, we do have a vertical shift. That means the center of my cosine is not on my x-axis, it's down 2. So our midline is going to be down here. I'm going to do it dotted this time just because I'm not going to erase it. I don't care how you draw it on your graph, whether you do it dotted or solid. You just want it to be faint so you don't confuse which one's your x-axis and which one's your center. Then we need our amplitude. We need that piece too. And it's the number in front over here. It's that 2. And what that tells me is my cosine, which normally starts at 1, is not going to start at 1. It's going to start 2 above the center. Because I'm going back for a second. On our parent function, it started 1 above our middle. So on this one, it needs to start 2 above our middle. Okay? Clear where that is? So since my left endpoint is at 2 pi, this is my start, but we're going to start 2 up. So this is my left endpoint, and I did that in the wrong color. Right here. This is my left endpoint. We went up our amplitude. This is my, I'm just labeling it here so we see where that is. That's my left endpoint. That works, close enough. And so my right endpoint is going to be at 6 pi, and it is also at 1. Remember, our endpoints are going to match. So this is also going to be up here. That's my right endpoint. That also is going up my A, the amplitude. Halfway between them, where are we going to have a point? At the 4 pi. Where is it going to be vertically? Up here? What does cosine do? So we're starting up and we go down. So we got to go how much? We're going to have to go below our center, right? So it starts above, we need to go below. So it's going to go down below the midline another version of that amplitude. Because if it goes up 1, it's also going to go down 1. If it goes up 2, it also needs to go down 2. So this also goes the amplitude. It just goes from the center. Since we had that vertical shift, our center just got moved on us. So we're going to have our first kind of cosine cycle is going to look like this. Then we just repeat our pattern. So we're going to say you could also hit those 0 points in the middle. Like if you want to dot them, go for it. Our zeros are hitting right in between our two amplitudes. So we can go with our 0, down 2, 0, up 2, 0, down 2, 0, up 2. It's just that our 0 isn't on our x-axis 0, it's on our midline. It's at the midline. So the rest of our cycle is going to go like this. And it's just super tight because it is with that weird scale because we had to count by pi's since it was so elongated. So what is the domain of this cosine function? Negative infinity to positive infinity. For sine and cosine, it will always be negative infinity to positive infinity. What is our range on this one? -4 to 0. So the range is going to change based on what our transformations are. But our domain is going to be from negative infinity to positive infinity. Okay. Questions on this one? What's up? Oh, no. Why did... That was weird. I was making sure I wanted to do this one next. It just froze on me. Yeah, this one's fine. So let's look at this one. It might do a weird on us again because I'm looking at a thing. Okay. All right. So let's look at this 3 cosine of x minus pi over 4. So again, we want to find the period of the function. We want to find our left endpoint and our right endpoint before we kind of figure out what else we need to do. All right. So the period of the function we get by taking the normal function and dividing it by b. So we take our 2 pi and divide it by 1. So the period length on this is 2 pi. We love that. To get our endpoints, that's when we take this piece here and we figure out when that would be what we normally expect it to be. So we're going to look at our x minus pi over 4, and we want to know when that equals 0. So our left endpoint is going to happen at the point, or at angle pi over 4. And our right endpoint, very similarly, we want to know when x minus pi over 4 is the same thing as 2 pi. So our right endpoint is going to happen at, what's it going to be? Not 2. As I say, it's not going to be 2 pi over 4. Think of 2 pi as 8 pi over 4. 9 pi over 4. Or 2 plus 1/4 pi. Common denominator before we try and add them together. Okay. So we know we need to be able to get from pi over 4 to 9 pi over 4, which is just barely past 2. So we can count this in the normal way, like the way we started with our 4 spaces to a pi. We can do our pi over 4 here, pi over 2, 3 pi over 4, pi, 1, 2, 3, 4, 2 pi. This guy's going to be our 9 pi over 4. I'm doing a kind of chaotic numbering, but that's okay. As long as it's counting the same scale, you can number whichever pieces your little heart desires. Is our midline going to change at all? No. So our center line is going to be right on our x-axis. So we don't have any midline shift at all. But we do have an amplitude change. Yes, dear?
Okay, how did you know it was a midline?
The midline shift would be added on the end. That would be our k's. So if it got shifted up or down, plus k would be on the end. So since we don't have anything there, we do not have any vertical shift. That's why I label everything with the A, B, H, and K. It's because we're familiar with K and what it does. K moves us up and down. It's all it does, instead of trying to have to memorize what each portion of it does. All right, so we have our amplitude. That's like our A value over here. Amplitude starts with A is how we remember that. So we know this is going to be 3. So what that does is when I do my left endpoint, that's going to be at pi over 4, instead of my cosine being at 1, we need to go up to 3. So we go up our amplitude to get to that left endpoint. So we're at the right angle, but the correct height is with the amplitude. Our right endpoint on cosine is always at that same height because we go all the way back to the circle and we go back to the start. So on our 9 pi over 4, we're at that same height. So here's our right endpoint, just so we're clear where I'm getting these pieces from. You don't have to label each of these pieces. I'm just doing it so we see where this is in case we go back and look at it later. How can I fill in the middle pieces here? Halfway through. So here, where are we going to go? Down 3. 1, 2, 3. Down here. Because halfway through, it's at the exact opposite side of the circle. Halfway between each of those is where we hit our 0. So it kind of looks like a V. Don't make it a V. It's a curve. But, so we're going to go skip 0. Skip down 3, skip 0, skip up 3, skip 0, like that. So to graph this, we're just going to connect them up. Curvy, not straight lines. Do not use straight lines. It is curvy wiggle city. What's up? Halfway between our endpoints is going to be our other kind of extreme value. Halfway between those is where we have 0. And then we just follow the pattern. So it was 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0. Or in this case, 3, 0, negative 3, 0, 3, 0, negative 3. So we just got to kind of find the way our brain pieces that pattern together and go from there. So our domain, negative infinity, positive infinity, and our range, negative 3 to 3 with brackets. Okay. All right. So honestly, those are like all of our transformations. That's how we do it with sine and cosine. you say, we have 10 minutes. If you want to, we could do another example, or you could have time to work on that homework kind of packet thingy. Because there's like 8 of them on there. Okay? So not do 129, clearly, because that's today. So tomorrow at the earliest, if you need another day, because I know these graphs take a while, that's totally fine. This is today. What's up? Oh, for the homework? I have it on a packet. Just that way you don't have to. Right? So that's what you're asking about. Okay, cool. Yeah, it's on the packet just because I didn't want us to have to come up with 8 of them. Ew. So I'm gonna put 30. If you need a day, take a day. Like, I get it. Okay, look. Oh, these are, we already did quiz 2. We're just gonna group. All right. Boop, boop. Please make sure you register for the IU portion. I intend to this week go through the list and see who is and isn't registered. Yes, dear.